Well, good morning or good afternoon, wherever you're at. I appreciate you spending the time with us today very much. Like we said, we're going to talk a little bit about what it's going to take to make your journey into executing against AI and ML projects within your organization successful. And kind of where I really want to start with this is definitions. And I like definitions a lot because I think a lot of words in technology are overused and people are left to guess what some of these definitions mean. Digital transformation is one of those definitions that I think is dramatically overused and nobody really has any concise meaning around it. And so the definition that I've used and I've used for a long time and that we'll think about within the context of this presentation is that it's fundamentally the application of technology to a physical asset in order to gain unrealized value from those assets. So if you think about a lot of the early stages companies like the Ubers and Airbnbs of the world, where it's how do I find, value in physical assets, or help in these cases other individuals find additional value in their own physical assets. That's really all that they've done when you really think about it at the end of the day. The challenge is that most people tend to think that digital transformation was this notion of going from this and everything that you see in this picture to something like this. And what I would say and what I would contend is that this isn't actually any type of digital transformation. This is just a standard technology curve of smaller, faster, cheaper over time. The real transformation that took place was taking all of that stuff over there on the left, not just shrinking it down, but making it consumable by someone of this age. We've all seen it, those of us who've got kids these days who are a lot younger, how quickly they adopt technology and how they adopt it really quickly, and how easy it is and intuitive a lot of these devices are for children, even with no background in the technology, to actually be able to use it. So with kind of that as a backdrop, let's think about some of the things and some questions that you might need to ask yourselves as you guys start to frame your transformation and start to think about how you start applying the technical capabilities of AI and ML and analytics in general to your business in order to start gaining that value that you're looking for. So the first one is do your business units use data and analytics to make decisions effectively? Most of us, and we'll talk about this a little bit more, but most of us have got BI organizations that are very good about telling us what we did, but not as good about telling us what we should do or how we should do things in the future moving forward. The second question is, do you understand your organization's key business initiatives and how or where to apply analytics and machine learning to drive those initiatives, right? We tend to think, particularly if you're coming from an IT background, that we'll create these systems and give them over to the business units, and the business units will naturally be able to use these things effectively. And oftentimes we're defining them or designing them in a cloud without really understanding what we need to build for and actually what the business units are looking to solve for in applying these technologies. Do you have business unit leaders' active participation in mapping their use cases to their initiatives, right? As you think about what the initiatives of these business units have, they're always sitting there saying, okay, here's the series of questions. Here are the things that I need to better understand in order to drive and make these initiatives attainable. And as we're designing and we're thinking about what we're solving for from an AI and from an ML perspective, we need to be able to sit down with our business unit leaders and understand exactly what those things are and how they're going to apply them to their initiatives. An interesting conversation that's started to gain a lot more traction lately is, do you understand the economic value of your data and how it impacts investments into AI and analytics and ML? There's been a lot of work done that came out of the University of San Francisco, University of San Diego, some blogs that have been written pontificating on this. But the idea is, and I think one of the things you'll hear Michael talk about as he goes into his segment, is that data exhibits what I tend to call the multiplier effect in economics, or a networking effect, where the value of data might be there for a specific thing or one use case, but as you understand that data and you understand your use cases, you're going to find that a single piece of data is going to start having this continued impact in multiple use cases. So for example, if you were in retail and you look at point of sales information coming off of your scanners, you might say, okay, I understand how to apply this to a sales metric, but how do you then also use that and integrate it into marketing? How do you use that and integrate it into your logistics and supply chain? How do you use that and extend it into your in-store displays and where inside your store you might put certain things, right? So a piece of data has a lot of value that grows as you apply it to more and more use cases. And then lastly, do you understand how to create a platform that allows you to exploit the economic value of your data? And this is really the hard part in the end state in a lot of the early data science types of functions as you identify and define what needs to be measured, the levels of granularity you need that information. That kind of understanding of your data, and then again, how it's going to be applied to your business initiatives really dictates the technology that you need to purchase. Technology in these processes tends to be the last of all of the decisions that you make. And it's really about understanding what you need, what you're trying to solve for, and then what types of data and levels of granularity you need to answer those questions. And that dictates what your platform looks like that you're going to end up running these processes on. So if you think about it, there's this very long-winded chart that a long time ago with someone else. He was primarily the one who created this, but there was a lot of bidirectional input on it. And I keep it in place because I think to a large extent it's more or less exactly accurate. And the one thing that I would point out is when we talk about this being, a big data or IoT or AI business model maturity index, the word business gets repeated over and over again, because if we're not building these systems to actually drive our business goals, there's not a lot of point in doing it. But when you think about this from a maturity perspective, your first phase, and pretty much where everybody is we're all very good on monitoring. I've got a lot of data warehouses. I've got a lot of systems that are in place that will tell me what did I do last Tuesday and what did I do every Tuesday in the perpetuity of Tuesdays I have in my system. And it's good at starting to look at what sort of data sources you're trying to capture. It's when you start applying key business processes and the economic drivers to that monitoring to derive insights and actually go through the process of starting to create some analytic models, you really start progressing into that next step. And this is where many customers today have started to dip their toe. They're starting to expand in, and now what they're trying to figure out is, how do I take that next step and take these things that I've started to learn and insights about my business that I've gained and move them into real-time optimized decisions. And this is really where you're saying the basis of my insights has moved from giving a report to a business unit leader who then makes a decision on how the business is going to run, or changes to a system, or makes a decision to do a repair to an assembly line process and says, now I'm going to give it over to the machines. I've taught the machines well enough to understand that when I see these indicators, my machine learning or my artificial intelligence systems are going to go ahead and optimize and make these decisions for me in real time. I trust them enough. And that's really that heavy move into that next phase of artificial intelligence and machine learning. From there, the fourth level in this model is monetization, and I want to be really clear. What we mean by monetization is not that this is the point at which you start realizing a return on your investment. This is the point at which you as a business know so much about a thing, whether it's your business, whether it's the automotive industry, whether it's whatever it may be, engines, that you know so much that you're actually capable of selling the information that you know. And when you get to there, you enter that fifth phase, which is really the metamorphosis phase, where even today, I would say there's only a small handful, maybe 4 or 5 companies that have truly landed at this stage. I think of Monsanto's, I think of John Deere, where they've changed their entire business models from just producing a product to now selling information as the core function of their business. Interestingly enough, if you look at John Deere as an example, and again, they're very rare, John Deere's tractors are no longer really their primary form of business. They are the instrumentation device by which they collect the information that has become their primary form of business, which is the selling of agricultural data back to farmers so that they can optimize their crop yields. And as you progress through that and you hit that final stage, you start really changing, you know, how you view data in your organization, migrating from just capturing to creating models to now having a really solid data analytics platform that's capable of delivering against AI and machine learning, to now having a business review and look at the data that you have as functionally being corporate assets, to then even potentially looking at data as currency. As you go through this and as your business models continue to change, it's taking that learning and best practices and constantly reprocessing them and updating your models and updating your AI algorithms and your machine learning algorithms to continue to drive and feed the business, and then eventually even potentially move into the creation of smart entities. And I use smart here in a very specific way, and that is, you know, entities and devices that are able to self-diagnose, self-understand what's going on, whether that's an assembly line, whether that's you know, an omni-channel marketing program, and being able to change where it's putting things in the market based on you know, real-time understanding of feedback in consumption, in, you know, whether it's social media or anything else, and then making changes to itself to optimize it to continue to execute its processes. This is really what we look at from a maturity perspective, from a Red 8, from a SFL perspective. I think, you know, our real goal is to really help you guys accelerate through and move from phase 1 or where you're at in early phase 2. If you're deep in phase 2 now, then take that and optimize that and help you input and build those automated processes to allow those systems to help either augment or make those decisions for you. That's really the core part of this, getting into the individual nuts and bolts. This is where I'm going to turn it over to Michael, and I'm going to let Michael go ahead and step in and talk about SFL Scientific and be able to answer your questions about specifically how we help you on this journey, and by doing so, ensure that you guys realize the success in your analytics, in your AI, and in your machine learning projects that you have as an organization. So with that, Brian, I'm going to stop sharing and turn it over to you to pull up the other slide deck.
Perfect. Excellent. And then just check everybody can hear me, correct?
Yes, sir. Yes, sir.
Yep. Awesome. Well, and Brian, I'll just yell out when to change the slide. So thank you. You know, quick thank you, obviously, for everybody joining into Red 8 for hosting this. So I'm going to dive a little bit deeper into the weeds here and really start thinking, you know, practically about what it means to take this journey in the AI kind of community and saying, where do we fundamentally need to think strategically? How do we think about the engineering? How do we think about use cases? And really, what's this life cycle look like to actually be successful here and move from these failed POCs to actually production grade AI systems? That's a significant amount of information to share in a very short amount of time, so I won't cover too much of it. So please, if there's questions, if there's follow-up conversation after this, I mean, I'll just tell a bit of the story. There's a lot more to it, so please don't be shy to follow up. Brian, next slide, please. So, oh, I can see all your slides. There you go. Perfect. So I have a few very quick intro slides just to level set and provide some perspective of who we are, what we do before we jump in. And by no means this is a sales pitch in any stretch, but I'm just trying to get you to appreciate the community that it takes to solve some of these problems. And then we'll dive in a bit more. So as a very quick summary on myself, my name is Mike Segala. I'm the CEO and co-founder of SFL. I did a PhD in particle physics back about a decade ago already, right when the data science space was really starting to take form. And coming out of that PhD program, my co-founders, who I also did a PhD with, we founded SFL with the focus of really bringing kind of our academic rigor and knowledge of solving large scale, big data, algorithmically heavy challenges in both the commercial and federal space. And our goal as a company is always to work on these really impactful problems, right? And that's what we're aligned to. Brian, next slide, please. So we're a US-based consulting company, and our job is to work with customers. And I don't know exactly who you guys all are, where you're coming from, but a lot of these problems are extremely unique and extremely bespoke. So what we try to do as an organization is really think through, what does it take to solve some of these problems? Because there is no one size fits all. There is an absolute community needed to solve the kind of entire life cycle of problem spaces that go into real AI workloads. And that's where we're trying to align ourselves. We have the honor of being NVIDIA's 2-time Partner of the Year for all the work we do in collaboration with them for really delivering best-in-class solutions. And when we work together, right, we don't actually retain any IP or do anything like that. So it's a very unique space to create something, because a lot of AI is differentiated to that specific customer. And that's what you're going to do, to Brendan's point, to really think about what's that change agent, what's that monetization strategy, what are you going to be doing that's novel, that's going to make you above and beyond your competitors. All right, next slide, please. And then we'll hop in. So as a consulting company, we've worked across an extremely wide range of projects in portfolios and verticals and things like that, both in the commercial and the federal space. So we have a very unique look into what does it really mean to solve AI, what verticals are actually being successful, what small use cases we see are actually being deployed, and being able to ground that in some realistic conversations of what does it mean from an investment perspective and an outcomes perspective of how to actually attain AI. All right, next slide, please. All right, so, and we touched on this already, as folks begin to and continue to invest heavily in the space, true adoption of any technology, especially this kind of technology, comes with a lot of clear challenges. So like anything, there's always going to be this high barrier of entry when you're building any new technology unit. And that's regardless of if you guys are looking to buy something off the shelf from a vendor or you're looking to develop something novel yourself. There is no easy button in AI. That's just not how it exists. People might sell that to you and market it because they're good at marketing, but by no means is it that trivial of an exercise. So if you're thinking about this from a leadership perspective, you're really going to have to invest that time, that knowledge share in these operational outcomes to actually successfully adopt this. Because unlike traditional kind of plug and play software, that is not how AI solutions are built, right? You have to really think strategically around my data capture, my modeling strategy, the generalizations of such models, how are they going to deploy, the governance, the security, right? At the end of the day, AI is still, and it will always be, an R&D initiative. It might be a lot more D than R in many cases, but there is no clear functional spec that you're going to put in front of an engineer and they're going to code it up like they would do a nice UI. It's absolutely the opposite of how real AI projects are solved. So you have to get out of that mind share of it's this kind of linear process. And because of this, we see a ton of, this is by Accenture and Sloan and Harvard and all these folks, right? Like a ton of these projects really do suffer for getting really any ROI out of it, right? There's this common thread. A lot of these pilots fail, and there's a lot of things that in these failure modes are preventable. So what I'm going to very quickly talk through is what you should be thinking about as you go through this journey and where you can mitigate some of those failures, because they are absolutely preventable as long as you're thoughtful about the process. Next slide, please. So, and before I do that, I just want to say, and this is really irrespective of the vertical that you come from. So when you think about AI, it truly spans pretty much every array, line of business, vertical scenario you can think of. And here's just a couple of quick examples that we've worked on. But the point here is to showcase, when you think about machine learning or data science or AI, right? This is a kind of nebulous word cloud. It doesn't really matter what we want to call it. It's math. When we think about the math problem at hand, there's fundamentally 3 types of problems that we're going to encounter. We have a computer vision problem, we have a time series problem, and we have a natural language processing problem, right? So we can have images or video, we can have something that is temporal in nature or signal processing in nature, or we can have things that are spoken word or audio or written, right? These are fundamentally the problem spaces that exist in all of the world, right? There's really nothing else that's unique there. So I want to highlight here the importance of thinking about when you're going after these problems, you're really trying to create these unique systems to capture, parse, and analyze this information, and then create kind of tools that will then have a profound impact back on your cost and your performance and everything like that. And folks that are really best equipped from a strategy and implementation perspective to understand, regardless of your vertical, regardless of your use case or your customer, what it takes to solve these problems are going to have profound, competitive advantage against your market in the future. Next slide, please. All right, so here are the basic building blocks, and then we're going to dive a bit into each one of these in the subsequent slides. So when we think about data science or AI or whatever we want to call it again, people tend to think very hard about the algorithms and the latest and greatest methods used to really solve these problems. And we get into all this fun talk, right? Deep learning this and neural net that, right? It's the fun stuff. The problem is, to implement AI is much more than just developing some algorithms in a box. It doesn't work that way, right? You truly need a holistic strategy and implementation plan to get there. So when we think about it from our side of the view, right, in our practice, we're working with clients across this entire development pipeline here, right? Starting from strategy, meaning sitting down and thinking through, where do we start? What are the use cases we're going after? What is the ROI attached to each use case? How are we going to measure the outcomes of the use case? What data is required? What are the data qualities, the standards, my internal personnel, the external vendors, right? And really articulating this strategic roadmap around data and AI that maps very clearly from a use case driven point of view back to outcomes. So you're going to have to start there. So after that, right, then it's time to think about the data engineering pipeline, right? How do we collect? How do we store? Are we anonymizing? Are we governing? How are we scaling our data? Do we need to authenticate? What are we trying to do from an R&D point of view, an operational point of view, right? And really bridging this kind of critical junction between subject matter experts and users to think about the inputs and the outputs of this system. And for us, right, this is where we have a very tight relationships with folks like Red 8 or NVIDIA or AWS or whomever that will help, right, establish these compute infrastructure, the storage, or whatever is required for us to actually solve the downstream AI use cases. This third junction is really, the more the fun stuff, right? When we actually get into the use case development, whatever the use case happens to be, for us, this always starts with a POC, right? A proof of concept. And we're always thinking about how do we time box a problem where we're solving that in a matter of weeks to prove it out from a technical standpoint. Meaning I want to take a problem, I want to say in 4 to 6 weeks, how can I showcase that in a environment that I understand, I can showcase that the algorithm works. And then if it does, move that into a scalable and operationalized environment. And going through this entire pipeline is really where we've seen and where we advocate for you guys to think and be successful such that you're going to mitigate against any false starts. So let's dive into this a bit more then. So can you go ahead? Yeah, one more is good. So if you're a stakeholder and you're thinking about, these big buckets from a data strategy perspective, it's important, as I mentioned, to map modalities and AI technologies back to your relevant AI use cases. And then thinking, do I have the time and do I have the budget? And most importantly, do I have the skilled personnel or the partner ecosystem that can help, right? Without the data, without the people, without the technology, you can't really solve any problem correctly. You might fool around with a couple POCs, but those 3 levers are really going to be important to do this holistically. So what we also want to think about very clear is anytime we establish a true AI strategy, the outcomes need to be rooted in a concept of true measurement and standards against those measurements. Meaning, if I build a system, I need to understand how I'm tracking that data, how I'm tracking the predictions, how I'm tracking the outcomes, how I'm deploying that. Am I measuring lift, right? Because most AI use cases are probabilistic outcomes. And that's a hard thing to think about if you don't come from the space. So what am I going to do to wrap that into a logic from the business's point of view and the technology point of view where I can track that measurement and educate my end customers, be it internal or external, such that they truly understand the impact of such systems. And you have to do that from day one and make sure that you're educating whomever it is that's using these systems away from the fundamentals of the complexity of the model, but really about how are you measuring the outcomes of the model, which oftentimes is a nonlinear and difficult process. So that's first and foremost. Next slide, please. So one of the biggest things that I get asked about, and I just want to share as well from a strategy perspective, is the why now, right? Why now isn't just because IBM puts out cool commercials and they make us think all great, right? Cool, they have really great marketing. But the question is really what is happening in the industry that should tip you in the direction of wanting to invest, right? Because this is an investment cycle of why do I want to put real capital and resources against AI? And there's really kind of four common themes that drive this. The first is larger data sets. We now thankfully have access to faster and cheaper storage, which allows us to store and then subsequently train more representative models with higher and higher accuracy. So, and this is for organizations looking to automate processes or doing whatever they're trying to do. The idea here is if we can capture more information, we can use that information to learn something dynamic about a system. So it's not really just about bigger data, because bigger data doesn't really matter always. What the second big thing is the unification of different types of data streams. So this could be from third-party data, it's social data, mobile data, sentiment, sensors, whatever it happens to be, but this aggregation of various sources enables us to learn really kind of non-linear or non-trivial things about a system, which makes it more predictive and makes you more unique and, yada, 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 getting to a place where you have something novel to share. The third big bucket is really the kind of ability now to process from a compute perspective. Basically, we can take lots of data and we can throw it at these really large GPU farms or whatever it is, because now we have access to low-cost computing. It's still very expensive, but in comparison, it's much lower than it's ever been. And we have new on-demand bursting computing and all sorts of databases models, right, that actually allows us to get to this place. Then finally, the biggest thing that puts us over the hurdle here, which I think a lot of you folks might be interested in, is researchers every single day are creating new open source models to attack different problems. So it's always extremely true that even if a problem wasn't solvable a year ago, the odds are today you've probably made enough advancements from an algorithm community that they're now attackable, or the data is now representative, right? So we're always striving daily to put out net new architectures to solve some of these ML models that makes new problems always accessible, and then deeper in the sense that we can get deeper in terms of our prediction. All right, next slide, please. All right, last one of these, then we'll hop into more of the data engineering side. So two things that I want you to think about, in terms of the buckets of AI, right? This is just an easy way to think about big buckets. You usually do AI to do one of two things. The first one is operational improvements, right? If you think about automation, right? Augmenting an analyst or creating some of these monitoring systems, right? So that, the automation side of the house. Here, there's usually a very clear-cut deliverable, meaning, I have a system, that system has a set performance and speed, and the output we can measure, right? When we have these kind of systems that are extremely linear, you can map that very quickly back to a tangible ROI, and you can do your thing, right? That's not that hard, and it's not that it's not hard, but it's not hard to map out from a business process perspective. The second area where we frankly spend a good chunk of our time is around creating kind of novel systems for R&D and kind of product or service specific objectives. So these are usually really complex systems ranging from, diagnostic tools to autonomous systems where, this could be in defense or healthcare or manufacturing, whatever it is, right? And the goal here is always, how do we create something novel that the core technology, right, is really about kind of AI algorithms to do something specific that will create something novel in that space, right? This could be in drug discovery or, all sorts of different areas. The problem with this is the ROI is usually not very clear to map out, because it's not like, hey, these two people used to do this, now my AI system did it. They used to cost me 100K a year, so I saved 200K, right? And a lot of these R&D systems, it's not that linear. So you're gonna have to be very thoughtful about the way that you present it back to the business, such that you're clearly articulating the ROI from that system and then thinking backwards into what it will take to get there. All right, next slide, please. So that was very, very quick on strategy. Again, there's a lot to unpack there, but just trying to get you into this idea of thinking about this. One more slide. Perfect. So as part of any kind of roadmap that we're thinking about, a big focus, if you really want to solve AI in a serious manner, is on building a kind of modern compute framework to support any data store or security or high availability and deployment and all that good stuff, right? And if you really want to extract value from machine learning, you as an organization and companies must solve kind of this underlying challenge within the framework of ML operations and management, right? And this is, how am I going to deploy it? Where are we going to develop it? What are the operations? What are the governance? Do we have the right systems to ingest the process? Can we actually output? Do we have, all the fancy BI tools and everything to visualize it, right? And setting up this entire ecosystem. For some folks, right, this could be really small and very low in complexity and very low in compute requirements. And it probably would map pretty clearly back to these simplified blocks here, and it's not that big of a deal. But for others, right, the big Fortune 5s that are looking to really, the Fidelities of the world that have tens of thousands of models in production that need consistent data management and orchestration and maintenance standards, this becomes an extremely complex task. But at the end of the day, the basic elements are all the same, right? It's just with greater scalability, you come up with more and more nuances to your architecture. One of the problems here, and I think we've gotten much better at it, and as some of these larger tech companies mature, they get better at their offering, but there's still no one size fits all here, right? Everyone has a very specific need with their legacy systems or the systems they're trying to create now. And, there's not just, press this button, my architecture deploys and everything's good. People will try to tell you that and sell you something, but there's always going to be something novel about your system that you're going to have to think through. So what I would advocate for, before we move on, is to say, sure, you have a very tight relationship between your IT side of the house and your data science team, and understand very clearly the limitations and the requirements that each one of these kind of business groups require. Because if on the data science in their small sandbox, they have, the biggest GPU farm in the world and they're doing all this great stuff, but really in production, IT says, well, you can't have that. It doesn't work like that. Or these services are not white labeled or whatever it is. It completely changes the dynamic of what each one should be doing to ensure that they're successful when this project needs to be deployed. So a really tight relationship from day one between those two groups is absolutely key to be successful here. All right, next slide, please. And we'll go one more. Perfect. So, yep. So I wanted to, now we're on the third bucket, right, which is the algorithm side. So for the algorithm side, I decided to actually showcase a really difficult use case because it will start to speak to the complexity of algorithms. Because again, in this space, I think there's this unfortunate feeling that you can just download some algorithm code off of GitHub and within 5 minutes press play and create something new, novel. It doesn't really work like that with real world data in hard systems. So what I wanted to do here was kind of give you guys a use case, one that we've been working on for quite a while now, just to show you how complicated some of these projects become. All right, so here we're going to focus on an image-based detection of disease, where the challenge is really geared towards annotating data and then building a very high performing set of algorithms that need to be deployed in a controlled environment, right? So this is for healthcare, but it applies in pretty much every other domain vertical as well. So the goal of this use case was to create a set of 23 unique deep learning models that would detect 23 separate conditions within the paranasal sinuses. So if you think about, your sinuses in your face, we can get up to 23 different diseases that grow there. And we want to be able to find those 23 diseases above human accuracy, which for, 20, 30-year trained radiologists usually sits around something like 93%. So what you have to realize here is, some of these conditions are extremely small in voxels. And I know you guys don't know necessarily what that means, but think about a pixel. It could be only just a few pixels big out of, billions of potential pixels. How do you find that and ensure that you can localize that and say definitively, yes, this is benign or it's cancerous. It's an extremely difficult problem. Next slide, please. So the first hurdle in a lot of these projects, especially here, is getting label data. So for us, it was about a year-long journey, give or take, to get about 20,000 hand-labeled three-dimensional CT images. And for a lot of these use cases, you can't just outsource the labeling of this data. It has to be done by a certified radiologist, right? Which makes it just a lot harder and obviously costly. The cost of the training data here alone is about $1 million. So not all use cases will be this complex. Some you can get training data, for free or for thousands or tens of thousands. But for these cases, right, you could be talking about millions of dollars just to build a training set. The biggest algorithm challenge in this space is really how do you generalize these models well beyond the base training data that you're given, such that in a real production system, right, when you're actually in the hospital or wherever, it will work on net new populations of individuals. Another big challenge is dealing with all, the standard problems in image, right? Was my focus or variability and, any other types of things that happen. And it's the same thing if you're doing satellites or drones or any images or really any time series or NLP problems. It always comes down to this, right? It's always a challenge. So there's this kind of misconception where we say we have a lot of big data, so if we don't get good enough models, we just get more and more and more data. Sure, that might be the case, but in situations like this, when you can't just arbitrarily say, well, give me another 20,000 images, because that's going to take another year and another $1 million, right? So what do you do when that doesn't work or when that's not an option? That's what I'm trying to get you guys to appreciate. It's not always a trivial out in real world problems. Next slide, please. So here's a look at a simplified workflow when developing these, these are decision support tools, right? So we call them decision support tools here. So what you'll see and what we advocate for greatly is, keep the human in the loop for all critical decisions, especially in this space of healthcare and other areas as well. So for example, right, we often build these kind of tiered systems where strongly past events can automatically be processed by the algorithm. So for example, let's say that we have this CT and we run our CT through the algorithm, and the algorithm says that at 99% accuracy across all 23 conditions, nothing seems abnormal, meaning everything is good. Sure, perfect. Pass that on. We're good with that. We don't need to pass that into a radiologist. The next layer may be the same, but instead of 99% accuracy, maybe it's 97 or 98% accuracy, right? So it's kind of weakly passed. So these results might then tier into a more specialized algorithm for further review, right? So a deeper review still algorithmically. If that fails, or say if you're less than 97% or something like that, then you can kick it to a human to have, that practical review. So, this does a lot of things, right? It helps you from a governance and a control perspective, but it also allows you to retrain these systems with more specific information as we progress. So when you're creating any imaging system or, not just imaging, lots of other systems, you should really be thinking about this high level design here. Next slide, please. And from an algorithm point of view, none of the 23 models that were created were, just off the shelf, right? All that we did had these kind of common 2D, we call them CNNs, which is convolutional neural net background, that backbone that was adopted then from 2D into 3D. But each one of these 23 models took very careful consideration on how do you attack a specific condition and then achieve that desired accuracy, right? And we're talking about 93% or above. And my point here is, and I've said it a few times already, but when you're dealing with real world data, that needs state-of-the-art performance, especially in healthcare or these other kind of, complex environments, you need to really think about generalizing and what it's going to take to solve this problem. And it's very unlikely that you'll just pull some code off of GitHub and be ready to go, right? Sometimes that might work for you guys, but oftentimes in our experience, it's not that straightforward. So just be very careful about that. And just because maybe one of your folks who wants to get into the space downloaded some code and it's not working, doesn't mean it doesn't work. It just means that they might not be advanced enough to really understand what it takes to solve some of these problems. All right, next slide, please. One more is good. All right. So the last one that we'll talk about here is, a topic that's really still in its infancy, but it's getting a lot of attention now as folks are actually moving some of these models out of POC and into production. The common name for this stuff is like ML ops or AI ops, right? Which basically means, once we build this model, right, how do we deploy it? What do we want to do to monitor it? How are we going to provide kind of continuous support and everything like that once this thing goes live? Next slide, please. So to visualize this, right, where we came from, now we're focusing on the right side of the puzzle here. And if we've done the hard work in determining the use case strategy, all our objectives, the architecture, and then, now we can start thinking about delivering, I'm just going to call it kind of this phase 2 scaling of our model into production, where we can really test it and debug it and validate the performance with real kind of live ingested data streams or whatever that net new environment's going to be. And as much as architecture determines how to scale these models, right, be it on cloud or on-prem or hybrid or whatever really you have, right, again, as I said before, the end users really need to be involved with both IT and the data scientists to examine the results, especially in production, and provide evidence that the workflow is still being successful and those models are holding up and the performance is holding up and everything like that. And to be completely upfront with you guys, right, this final bit here is where most pilots fail. They don't fail because of a technical feasibility in POC, right? If you give me some data that's well curated and I have all the resources and time in the world, it's extremely unlikely that I can't solve the problem. But most folks will fail because the data they've created or the model they've created or the architecture or whatever it was not purpose-built with this kind of generalization post-POC or scale post-POC in mind. So if you take away anything today, right, please really note that you should be thinking from day one, how would you deploy your models in production and how would your data look in production under the assumption that your POC of feasibility is going to work, right? So make that assumption. And what I want to say here is, don't wait the weeks and the months or whatever it is to actually showcase, your feasibility and POC to start having conversations with IT and whomever to actually do this, right? You can do those in parallel. You don't need to start coding it. You don't need to start spending money on the production and deployment side, but you need to have that plan in place from day one under the assumption it works. Otherwise, if the plan's not there, you're going to fail. And if the plan's not there and you try to do it afterwards, you're going to then create another lag of 3 to 6 months, right? So it's just really doing it up front, doing it in parallel is only going to make your process much better. All right, last slide, please, then I will be done. So, finally, working with us in conjunction with Red 8 will really allow you guys to get above the difficult barrier of adopting AI, and work together to really critically think about your specific use cases and challenges that you guys have. So this relationship is much more than just kind of standard fulfillment of goods and services. Rather, we're trying to help you guys develop something unique and custom, to your specific use cases and outcomes. Our mission at SFL is really to close your data science maturity gap, by teaming our SMEs with your SMEs to develop state-of-the-art solution. AI is hard, but with the right partners in technology and ecosystem, this could absolutely be methodically approached and solved. So with that, I would say thank you for your time today. I'll pass it back to Red 8 and happy to talk and answer any questions you guys have.